Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online session, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, everybody. Good morning or good afternoon, depending on where you are connecting from, and welcome to this ATA Insights webinar on the key aspects to securing a bankable CSP tower with molten salt storage. And well, today we have 3 experts from China, which is one of the main markets where the development of this technology is playing out, and they will be telling us all about this exciting subject. So first of all, well, before we start, I'd like to remind everybody of a tradition we have at ATA Insights, which is to introduce yourself in the chat and tell us where you're joining from. So I'm joining from Berlin, not so sunny. Definitely wouldn't install a CSP tower here. So I'll stop sharing the screen now, so you can see our speakers, and I'll get them to present themselves. I think we'll start with, well, in the order I see you on the screen. So we'll start with you, Mingjia, if you could please briefly introduce yourself.
Sure, no problem. Thank you, Carlos, and good evening, ladies and gentlemen. I'm Mingjia Li from Xianjiang University, China. Well, I should say thank you very much for having me. I deeply humbled and profoundly honored can join us from this webinar. Also, I should say this is also my first time. So it's my pleasure to share a little bit my research with you guys. So far, I think I'm mainly focused on 3 topics. The first is about the theories and technologies of energy efficiency, conversion, and utilization. The second one is about the energy storage. That's why we are here today. And the third one is about the biomass concentration, like something about the reduced carbon emission. And beside that, I also lead my research team. We developed some energy storage projects, and it has been already applied in the commercial market so far. So today I will share a little bit part later. So that's our very brief. Thank you very much.
Thank you very much, Mingjia, for the introduction. So we'll be all looking forward to your presentation later on in the webinar. And next, I'd like Shui Yao to introduce herself, please.
Yes. Hello, everyone. It's my great honor to attend this webinar to introduce our work. I'm Xuejiao Li, a research staff in Shanghai Institute of Applied Physics, Chinese Academy of Sciences. I got my doctorate from Shanghai University. During that time, I visited Georgia Tech to study for 1 year. Recently we drafted the first standard about molten salt corrosion. So in this presentation, I will interpret this standard in detail. That's all. Thank you.
Thank you very much, Yao. And then Andy, please introduce yourself and get ready to share your screen because you'll be the first one to present.
Okay, so ladies and gentlemen, good day. And thank you very much for your time. And also thanks to ATA for the invitation. And I'm Andy from Subcon Solar. I'm in charge of business development in EMEA, Europe, Middle East, and Africa. And by the way, I'd like to take the chance to share the news with you guys that from tomorrow on, Subcon Solar will change its name from Subcon Solar to Cosine Solar. Same people, same friendship, and the same commitment, but we will start a new journey. Yeah.
Thank you very much, Andy, for sharing these news. And yeah, well, whenever you are ready, please start sharing your screen and start your presentation. And in the meantime, I'd like to remind everybody in the audience that you can send questions. So it is your chance to send questions to our experts. And yeah, so if you've been to one of our webinars before, you know that we have a questions and answers box at the bottom and where you can send your questions through. And without any further delay, please, Andy, over to you. I can see the screen just fine, by the way.
Yeah, okay. So today we talk about the energy storage. It's a very popular topic, and it's a significant to harness the energy and also dispatch the energy according to the demand and also the grid safety. Today, I'd like to share my opinions from the point of industry, and later on, my fellow speakers, they will talk about their latest research outcome. And first, please allow me to have a brief introduction of Subcon Solar. So we are a technology provider for tower CSP, and we are actively involved in the international practice. So for example, in IEC standard, in the World Bank promotion program, and also we answer the call of the solar pieces for the technology innovation. Right now, we have 4 references in and out of China. In August 2016, we delivered the Molten Salts Tower CSP, which is the first one in China and also the third one all around the world. The project performance is quite well ever since. And this is the performance curve. So benefit from the molten salt storage, we can have a very stable output even in the face of fluctuation in the sunshine. And also we can have a continuous output even at night. So this is a project in Europe, and we are in the final stage of financial close. We are also in a tendering of totally 600 megawatt CSP. It's in Chile. In China, we have another 2 projects ready to build, so totally 235 megawatt. Okay, so talking about the energy storage, the first thing people think is a battery, because it's so common in the life. We have mobile phone, we have laptop, we also have the electric vehicles. Because we are humans, we tend to accept what we are already familiar with. But is a battery really a universal solution, or is it just an illusion? So in 2017, there are totally 27 fire accidents in Korea. And the ministry, they announced the safety policy, try to clamp down fire accidents. However, 4 days later, there was another fire. So what are the reasons leading to all these accidents? These are their findings: battery defection, insulation failure, dusty operation environment, and also by the system integration. And I'm sorry, I tried to share a sad video with you guys. Just give me 1 second.
So we have seen the video. Andy, I don't know if you.
Yeah, okay. So this is a accident in Beijing in April this year, and the 2 firefighters lost their lives in the accident. So really, is the battery bankable, or is it more reliable, or it's safer, or it's more efficient, or cost effective? I think it's quite different from what people assumes. So let's talk about molten salt and also the thermal energy storage. Actually, molten salt is not very mysterious because molten salt is mainly used in industry and not for civil purpose. So common people are not very familiar with the molten salt. And how about thermal energy storage? It is a very new idea. Actually, it's not. So ever since human beings began to stand on heat feet 1,000 years ago, we already learned how to keep warm. So this is where the idea comes from. And is the molten salt only used in CSP? No. For example, it's also used in nuclear power, also used in chemical industry. And is molten salt recently used in CSP? No. Because back in 1996 in USA, in Solar 2 CSP project, it's already been applied. But we do realize there are some challenges, and also there are some accidents related with molten salt. So for example, people here, there is one project, the molten salt got frozen in the pipe, and the whole downcomer becomes solid. Yes, it's true, but is it unavoidable? No, it's not at all. This is why we have all the heat tracings follow the whole route of the molten salt flow. So why it happened? So what's the reason? Here are some of our assumptions. How about the heat tracing? Does it work well? Or is there any redundancy for the heat tracing? And is there any alarm for the low temperature to the operators? Has the operator spotted the alarm? Or if he already spotted the alarm, what action did he take? And if there is no alarm for the low temperature of the molten salt, then how about the temperature transmitter? Does it work well? Or is it located in the correct monitoring point? So this is our assumption. Next topic is about the tank. Talking about the tanks, people think of leakage, then get very nervous and very concerned. But I'd like to ask, how many molten salt CSP do we have around the whole world? Almost 50. So there is one leakage, and it seems all the molten salt tanks, they don't work well. That's not right. That's not the way. So actually, engineers, they will identify what's the potential risk in the structure, and they will do the corresponding design, try to handle with the thermal fatigue and also the thermal shock. And the same thing happens to the foundation, to the basis. For example, engineers, they will optimize the design for the stress distribution to make it distributed evenly. And also, they will make a good ventilation for the foundation to prevent the temperature being very high on the concrete. And also the third thing we need to keep in mind is the workers, they have to be very careful. I mean, the welders, they have to be very careful. They have to follow the procedure and try to reach the standard. And the last thing is during the operation, special attention has to be paid to the impact on the flow of the molten salt. Next topic is about the pump and the valve. So they are a little bit different from the normal used ones. For example, for the molten salt pump, we use the long shaft pump vertically installed on top of the molten salt tank. And also for the valves, there is a possibility that molten salt can get frozen inside, and in this way, it will clog the molten salt valve to make it malfunction. And how to avoid it? So we have to make some special design. We try to extend the valve stem a little bit and put the heat tracing on the valve body, try to keep it warm. And another thing is we have to pay attention to the packings and the shims on the valve, just in case there will be any leakage. And the people also talk about the corrosion. So actually, the labs and also the research centers around the world, they conducted extensive tests on the corrosion on steel at different temperature and also for the different time durations. And their conclusion is the molten salt imparts very limited corrosion on the metal surface. So in the industry, what we try to do, we try to control the purity of the molten salt, such as the chlorine, the content of the chlorine. And also, we try to keep some extra margin in the metal thickness during the design. This is what we have from the SUPCON project, which already operating for 5 years. We take down one piece of the molten salt pipe and we check inside, and we can see it's very clean and intact, and there is no sign of corrosion from the molten salt. And the next topic is about maintenance. So actually, for the molten salt system, it's quite stable. And the only attention we have to pay is on the packings and also the shims for the valve and also for the pumps. So we only need to do a regular inspection and replacement for these parts. And luckily, this part is very easy to obtain, and the cost is not very high, it's quite cheap. So in this way, the OPEX is very controllable. And this is a summary for the molten salt system. Actually, it's already run for so many years, and we never see a big problem. And around so many projects around the whole world, there's only a few projects they meet some different problems. But we think, compared with the battery, molten salt, they will play a very important role in the future energy matrix. And we think molten salt as a energy storage, it could be applied in many different scenarios, especially for the large scale energy storage. And also we think molten salt It's quite reliable and also very efficient. It's safe. It's economics compared with the battery. So personally, I don't see any problem of the bankability. The question of bankability is only because people don't know it well, don't understand it well. So I suggest a positive propaganda is to be conducted, so people could be educated and also be illuminated and also inspired. And the last thing, but not the least, is the engineers have to be very careful. The construction workers have to be very careful. The operators have to be very careful. It's not because we are in the CSP industry, but it's because we are dedicated professionals. Okay, that's all. Guys, thank you for your attention.
Thank you very much, Andy, for your presentation. It's very interesting. And now, in the interest of time, I'll give the floor to our next speaker, who is Ming Jian. So whenever you are ready, please go ahead.
Sure. I just a little bit seconds. I begin sharing my slide.
Yeah, no problem. And
okay.
I can see them. If you could turn them to full screen.
No problem. Okay,
Perfect.
so shall I begin?
Yeah, over to you. Yeah.
Okay, thank you very much. So good evening, ladies and gentlemen. As I say my name again, I'm Ming Jian from Xianjiao University, China. Well, I should say I deeply honored and profoundly humbled can be here and share a little bit of my research with you guys. So my topic is about the applications of molten salt storage in CSP of distributed energy system. I'm not sure you might be a little bit confused why I'm not just directly telling the molten salt energy storage in CSP. I mentioned the part about the distributed energy system. This is because the market situation in China, the scale of the CSP market is far less than the photovoltaic power generation in China. So, which means the CSP market definitely needs the continuous politic support. And today in China, the CSP market has a very good opportunity, which means so far we are undergoing the 14th 5-year plan. And from the government side, they always mention renewable energy, particularly for the solar energy, should play a dominant role in the distributed energy system. So that's why here, in my humble opinion, I believe our CSP market can present well advantage in the situation with the part of the distributed energy system here. Okay, so I will begin my presentation from the following 3 parts. So first, about why it is important in carbon neutrality of China. As I mentioned before, let me zoom. Yeah, in the 2020. The Climate Ambition Summit, our President Xi Jinping has already presented the objectives of China, which is to propose the carbon emission peak before 2030 and carbon neutrality before 2060. We're not just saying about it, we also make very clear roadmap for achieving, such as the first one, we have to reduce 65% of the carbon emission per unit GDP compared with the level in 2005. And also we have to highly increase the total installed capacity of wind power and solar energy. So that's why we always mention the opportunities and challenges that are side by side. Of course, we have very good chance here. The steady increase of the renewable energy power generation for the installed capacity is very large. But in China, a large number of abundant of solar power and wind power also exist. So it's really necessary for us to improve the capacity of the renewable energy consumption to stabilize the fluctuation and intermittency And finally, to improve the flexibility of the power system regulation. Okay, so actually before, we already have some energy system, but I categorize it as a centralized energy system. Why? Because it's a very large scale, such as very large coal-fired thermal power plants. Its advantages is it has a high capacity and different working conditions with high load. But it also has a limitation, which is about if you connect it with the grid, the fluctuation will affect the grid security. So today here, we have to develop we call it source network load storage. This kind of character the distribution energy system. Why we see these four walls? Because these four walls, they have their own meaning, such as for the source, which means from the source side, it changed from single source or fossil to multi-energy complementary. For the network, means network side changed from the centralized energy supply to decentralized energy power. And sorry, just put it over there. And for the low side, which means it changed from the single power supply to multi-generation supply, cooling, heating. So which means we are in the third generation distributed energy system. It will be more clean, low carbon, efficient, and flexible. Okay, so of course there are very typical different distributed systems, right? But that's why today we talk about CSP. And CSP is energy storage. That's why we think it can effectively solve the fluctuation of the different renewable energy and instability of the energy peak load. We are familiar, this is a schematic diagram. So there will be scientific problems within the different process, but today, because of time, I only talk about the medium part, which is a novelty technologies for efficient conversion and thermal storage. What did we do in our groups? So this is about the second part. Of course, what is the idealized thermal system? We like it have the characteristic of the high rate, high density, high quality, and low investment, right? But this is a very idealized situation. And lots of problems we need to overcome, which is here. The efficient mechanism of the multi-phase and multi-scale and multi-carrier is not clear. Also, we have to design different complex structures and how does it go in with the different conditions. So we can conclude that the performance advanced methods should be improved. So from the material side, our group, we revealed the macroscopic mechanism of the different materials, such as molten salt, nano-composite phase change material, and also improve the thermal performance of it by adjusting the surface charge of ions and how does the microstructure going. So after these kind of the methods, the specific heat capacity is increased by around 17%. We did this with high transmission capacity and high density. So for example, this is a very simple example. We developed the single wall carbon nanotube composed PCM and graphene composed PCM. Through this kind of methods of these, the more conductivity and specific heat capacity are highly increased. You can tell from the figure and over there. This is about first part about the material. We also need to enhance the thermal storage process, but we know the high storage rate, it doesn't mean the high thermal conductivity. So that's why we need also to realize the mechanism. That's why we did the storage conversion rules of the steady state phase change storage process from both heat conduction and heat convection side. Also, we designed different structure in order to improve the performance. It leads that we highly increase the heat storage rate without affecting the storage density and quality. And the third part is because we are talking about the material and the heat storage process. And finally, it's about how does the structure going, the structure system. In our research group, we developed lots of research from 1 point to 6 point. But today, because of time, I'd like to share with you 3, 4, 5, which is about the sensible heat material and phase change material, and how does it influence with the system over there. Let's first see the sensible heat material, concrete single tank. So first we know, compared with the double tank, the single tank, it can save 35% of the investment cost, right? But which structure is the best? Because we design different structures from like the parallel plate, shell and tube, and backpack. That's why we have to analyze it from the thermocline part. So the thinnest one who has the thinnest thermocline will have the optimal structure. And from this 4 diagram up there, we can find out that the backpack system is the optimal choice. Okay, so based on the backpack system, and the next question is which material we should choose. We have concrete, cast iron, or the ceramics. They all have their limitations and advantages. So in our humble opinion, we have to realize the comprehensive advantage of each material. So we finally, after a very complex theoretical analysis, we finally choose the concrete and the cast irons and the quartiles to build the 3-level structure over here and make the performance comparison with the pure quartile. The effective storage is increased by 27% around it finally. And what about the phase change material? For the phase change material, definitely we need to have a phase change ball which can contain this kind of material. And why we adopt this ball, another advantage is we can enhance the heat transfer area, and the convective heat transfer coefficient can be highly increased. So after different parameter analysis, I just choose a very simple examples here, which means the different diameters, they always have the different results of the performance. So from these 2 diagrams here, you can find out that the smaller diameter of the balls, it will lead to a higher storage rate. But from the right-hand side, you will see the larger diameter of the balls, it will lead the higher density. What shall we do? Because we mentioned before, we want high density, fast rate, but low investment cost. That's why we finally do the comprehensive optimization. As an upper layer, we choose the larger ball with the diameter of 30 mm, and the lower layer, we choose the optimization of the small ball, which is 25 mm. So also we did the simulation analysis, and we also did the experiment test. Finally, the heat storage performance is enhanced and the heat storage rate is increased by around 8%. Okay, from until now, what I want to share with you guys is to have a bankable energy storage of our CSP. We have to do the synergistic enhancement method, both from material design, process enhancement, and system optimization. Finally, we can achieve these 3 high, 1 low, thermal storage. And here is our product. Our research team, we design and have the cooperation to connect it with the one of the parabolic trough solar power generation in Qinghai of China. This project is a concrete thermal power system, thermal storage system. And the advantage of it is compared with international level, our domestic projects, the investment cost is very low and the heat storage density is higher than that. So finally, it's another my humble opinion I like to share with you guys, because in my opinion so far, the thermal storage with CSP cannot be operated lonely anymore. It has to be contacted with a grid and network. So that's why for our experiment test, I also developed it. It not only can do the simulation with the network and load together to do the whole commercial building or the whole commercial area simulation, but we also can do the experiment test with the real load on this kind of the experiment platform here. Okay, so the summary about today's I'd like to share with you guys, which is I firmly believe the CSP system with energy storage is helpful to realize the large-scale and efficient utilization of clean and carbon energy. But we all have the very difficult problems we need to all come together. And finally, we can have the efficient, stable, economical, and safe operation of our CSP system. So that's all about my presentation. Thank you very much. Thank you for your attention.
Thank you very much for your presentation, Minjie. It's very interesting, and you know, I think yeah, the audience will definitely have follow-up questions. You know, I have a couple of my own, which I'll share after after our next presentation. So Shui Yao, please, whenever you're ready, please go ahead.
Yes.
Okay, perfect. I can see your screen, so over to you.
Okay. Hello, everyone. Recently, we drafted a standard entitled as Molten Salt Corrosion Testing and Assessment Methods for Solar Thermal Power Generations and released by CSTA. So in this presentation, I will explain this standard in detail. Here is the outline. Let's start from the introduction of molten salt. The definition of molten salt is an ionic melt composed of cation and iron. The powdery salts melt into liquid state and then cools into a dense solid state. There are so many advantages of molten salt. For example, the wide operating temperature range, the high heat capacity and thermal conductivity, the good chemical and thermal stabilities, and the low viscosity and vapor pressures and low price. Especially, the salt resources are abundant in China. In a word, the properties of molten salt can be vividly described as soft and water, warm and fair. So the molten salts have wide applications in many fields. Here we focus on the molten salts for CSP. This picture shows the main common salts, for including the nitrates, the chloride, the fluoride, and carbonates. The currently used nitrates, such as solar salt and high-tech salt, are not stable at high temperature. The new proposed chlorides are suitable for Generation 3 CSP above 550 degrees. However, the biggest challenge of chlorides is the strong corrosiveness. The external corrosion factor of temperature, pressure, and corrosion temps are important. Besides, the internal corrosion factors include two aspects. One is container, the other is molten salt. For the container, usually alloy, the compositions and machining and welding processes are significant factors. For the molten salt, it should be stressed that the pure molten salt is not corrosive. That means the impurities in molten salt is the main factors to the corrosion. Besides, the species and the compositions of molten salts are also important factors. From this table, we can see the raw chlorides contain a variety of impurities. In addition to the metal elements, there are also acid radical ions. So how to test the corrosion behavior of molten salt on contacted alloy container? The static immersion method is the most common method. The left picture shows our experimental equipment, including the high temperature resistance furnace the glove box and the temperature control cabinet. Here is the core component. Several perforated samples are suspended in the molten salt, which is put into a liquid, which is put into a crucible, where the choice of crucible depends on the species of molten salt. All the corrosion test is carried out under argon atmosphere. This is the flow chart. The alloy sample and the molten salt are sealed into a crucible. Two variables are considered. One is temperature, the other is time. This picture shows the stainless steel 316 in this molten salt. It can be seen that the corrosion became serious and the alloy changes from the bright to dark as temperature and the time increase. Furthermore, the weight, morphology, and the element distribution of alloy sample are conducted to obtain the corrosion rate and corrosion depth. Both components of alloy and solid salt are analyzed by the following instruments. For example, the SEM is used to observe the surface and cross-sectional morphologies. The EPMA is used to analyze the element distributions, and the XRD is to test the crystal phases of alloy. The SAPOES is to detect the ionic concentrations of molten salts. Part 3 is the detailed corrosion assessment, include the weight loss of alloy. The morphology, the corrosion morphologies at different temperatures. The corrosion depths observed from the cross-sectional SEM images, and the corrosion rate calculated from, the weight loss of the corrosion depths. From the element distribute by EPMA, we can clearly see the distribution of metal and non-metal distributions, and further analysis the corrosion mechanism. For example, the intergranular immigration of chromium can be found as temperature increasing, and the nickel transports from the surface to the inside of the alloy. Besides, the selective dissolutions of iron and chromium from the alloy to molten salt can be verified by the increased ionic concentration. In addition, the new phases are formed in the alloy matrices from the XRD patterns. At last, a corrosion test report will be completed, including the alloy sample information, the molten salt information, and the crucible information, as well as the corrosion test parameters and results. Here we have two versions in English and Chinese, and it's also open to the public. The outlook, based on years of research experience, some prospects are made. First, the dehydration of molten salt is important. Except for water, other impurities should also be removed as possible. Third, the reducing agent is helpful to inhibit corrosion. Fourth, the research of electrochemical corrosion is very important, especially the redox potential of ionic pairs in different molten salts. And last, the multi-scale simulations in combination with experiments are conducive to deeply understand the corrosion mechanisms. That's all for my presentation. Thanks for the funding support and our research team. That's all. Thank you. Thanks for your attention.
Thank you very much for your presentation. So yeah, it's very very interesting, and I'm sure that we'll have questions as well. I wanted to start with a general question, really. So where do you see, maybe Andy could start answering it. What do you see? Which role do you see CSP with molten salt storage playing in the energy system? Is it in some markets we are seeing it that it's been deployed to produce energy during evening peaks and after sunset, essentially. Is that the role that you see in China, or would it be different? What are your thoughts?
Okay, Carlos. So I think CSP with the molten salt storage will play a role mainly to cover the peak time. So from my point of view, and during the off-peak time, I think it makes sense if there is another different technology, they are cost effective, they can cover the off-peak time.
Thank you. And I don't know if any of the other speakers would like to add to that, to the role of CSP in the energy system.
Yes, thanks. And first, I agree with Andy. And what I like to add comments is I also read this question in question and answer box over there. What I want to add my comments about 2 points. The first is why we always see CSP has advantages, even though about the night supply. First, because it has a good point with the peak load regulation ratio. We did research before because we always have this kind of question. How does the CSP can make a comparison with the coal-fired thermal power plants, or how does it can be compared with the photovoltaic power generation? Our question here is first is the peak load regulation ratio is high. It's around 85%. So this is first advantage compared with others, which this figure means, even though in the night supply market, it also can give you a stable and without interruption power supply. This is about the first one. The second point is it has a very flexible load increasing and reducing ratio around like 5%, 3% to 5%. So which means even though you are the night consumer in the evening, but you also can use the energy storage, which is the energy can be stored, and the CSP can give you the very stable energy power. That's about my comments. Thank you.
Thank you, Ming-Ya. Xue Yao, I don't know if you'd like to add anything, or should we go to the next question?
Yes, I want to see there are 2 aspects to inhibit corrosion. One is the choice of the molten salt. You know that the corrosion of chlorides are generally stronger than that of fluorides due to the strong hygroscopy of chlorides. So choose what kind of, so which molten salt is better is depends on you, how long do you want to your molten salt storage tank in service. On the other hand, I think is the alloy. It is known that the corrosion rate in nickel-based alloy in molten chlorides are lower, but the costs are higher. Therefore, it's necessary to find a balance between them to ensure the lifetime of molten salt tank. Yes, that's all.
Thank you. Thank you. And, I have a follow-up question for Ming Jia Li about the use of distributed storage systems of these kinds. So I think we have definitely seen a lot of batteries that are being marketed as distributed systems, but rarely have I've seen these the kind of a thermal energy storage system being marketed as a distributed system. So, do you think I don't know if you've run the numbers? Is it how does it affect the economics? The fact that it would be, I assume that if it's distributed, it would be smaller, right? So do you lose economics of scale, or do you recover them from being able to manufacture them more of it?
Yeah, thank you, Carlos, for this question. I'm not sure, can I summarize your question as like what is the advantage of our molten storage compared with battery in the commercial market?
Yeah. Or on the distributed storage system.
Solar system, yes. Well, this is a good question. I prefer answer it from the two perspective. The first is about from the technical way. Technical way in the distributed solar system, we usually use the molten salt storage. So, I mean, this is very classical and typical choice. If we use battery, which means with the directly intention from us, which means it's definitely need to be connected with photovoltaic. Otherwise, because we are talking about energy has a grades. So if you have the conversion from the high grades electricity to the low grades, means like the more of heatings, you will lose energy. So that's why if you use the battery, which means you have to connect with PV. So electricity to electricity. If you want to collect a heating at a frontier point, which means thermal energy, and the most good choice is to connect with the thermal storage. This is from the technical way, the first point. Second point is from the friendly environment ways. We also did the research before to make calculation for the for the carbon emission of every kilowatts of the photovoltaic and battery together is 45 gram. But for our CSP with the more molten storage, it's only 29. So you will see the comparison is nearly 35% lower than PV with battery, right? So yeah, I like answering from these 2 points.
Okay, thank you very much. And Andy, I think you also covered some of the advantages of molten salt systems compared with batteries. Would you like to elaborate on this?
So for the batteries, I mean, I never say battery has no advantage at all. I only mean in some scenarios, it's better to use molten salt, and in some scenarios, maybe it's good to choose battery, but it's only depend on what kind of scenario. For example, what's the scale? What's the capacity we need? Yeah.
So my understanding is that at a high capacity, you're better off with molten salts. At lower capacities, you're better off with batteries. Would you agree with that?
Yeah.
Okay. Well, we have a question here about that is from Manuel Quero, and he's asking, it seems that all panelists agree that bankability is not an issue for thermal energy storage systems. But in your opinion, what should be done or what could be done to enhance the CSP market in the eyes of financiers? And he says, Andy, that you have answered this question, briefly, but if you could elaborate further on it. So just to summarize, what could be done to enhance the the CSP market in the eyes of financiers?
Well, sorry, after you, Andy. Yeah. After you, Andy, please go first.
Maybe you can share your opinions first.
Yeah, thank you. Well, anyway, what I want to say first is because I think you may address some comments on it before. So first, I agree with you, and second, I want to say it actually depends on the countries and on the different policy governments. I'm not sure about other countries, so maybe Andy can give us something of politics, maybe about the supportive politics in Dubai, how that's going. But in China, if the CSP market want to be widely open and widely has a more widely scales, the government policy, as I mentioned before, it has to be strong and be continuously be positive. This is not the new thing because why photovoltaics so far they have a strong advantages. Because that is because our government already given subsidies in nearly 10 years to continuously support the photovoltaic in China. So CSP so far we have the good chance by our 14th five-year plan. So this is really have a very, I think, strong relative relations with the government and policy. That's about my humble opinion.
Thank you very much. So government policy is key to making CSP more attractive. Andy, what are your thoughts on this?
Yeah, so actually I fully agree with Mingjia. Yeah, I think at this moment, because CSP, the industry is still very, very small compared with the PV So I think at this moment, we still need the government to give us some support. So for just now, Mingjia already take China as an example, and I'd like to take Spain also as an example. So people are talking about the CSP auction this year in Spain, but still there's not a very clear regulations, and also there's some conditions make the CSP quite hard. And this is not done by the industry. We can only try to persuade the government, but still they make the decision and we just follow the rules. And just now, Manu also asked about how to make the bankers or the lenders to accept the CSP or the molten salt. Because at this moment, there are quite a small capacity. If there are bigger and bigger capacity, all the financial institutions, they can realize, okay, molten salt works very well. There's the risk is under control. Then they can gradually change their mind and support. But if there is no project at all, how can they make up their mind? They can never see. So this is my opinion. Thank you.
Thank you very much. And I think, well, we have a couple of minutes, so we have time for one more question. And there is a question about the challenges of next generation CSP towers at higher temperatures. And I think Xue Jiao Li mentioned that higher temperatures lead to a higher degradation of the or high corrosion of the materials. So
okay, from the view. Hello?
Yeah, so yeah,
from the view of molten salts. Hello?
Please go for it.
I'm sorry? Yes?
Yeah, please go ahead.
From the view of molten salts, I think the next generation of CSP at higher operating temperature is the corrosion problem. The choice of alloy is limited. So the most important thing is how to purify the molten salt. I mean, just the impurity removal from the molten salt. If you can solve this problem, and the generation 3 CSP will go on, I think.
Thank you very much. So, And well, I'm sure that everyone in the audience knows, but the idea of actually going to higher temperatures is that you could produce more energy. But then, how do you keep the balance? If you start going too high temperature, then you might need to invest much more to keep the integrity of the system. So, what's the right balance? I'm sure that Andy and everyone is working on ways to address this issue, but yeah. Okay, well, with actually, as all good things, this webinar must end as well. So I'd like to thank everyone who's been with us today. We've had an audience of more than 100 people at its peak. So thank you to everyone who's been here with us, and thank you to our three speakers, Ming-Jie Liang, Andy Shao, and Shuijiao Li. And well, I don't know if you'd like to say a few words to the audience to as a way of saying bye.
Well, thank you very much for having us, and it's also my pleasure to share my humble opinion with you guys. So I think I like to mention again, CSP's market is really a worldwide corporation. We can overcome and together to make it better and make it more clean and low carbon. Thank you.
Thank you very much. Andy, would you like to say a few words, a way of saying goodbye?
And yeah. Also, I'd like to extend my appreciation to all the audience and of course the organizers. And I appreciated your interest and your support in CSP. And actually, we have a very strong confidence in the future of CSP, and we'd like to work together, try to promote the whole industry. Yeah.
Thank you very much. Shuijiao Li, any parting words?
Okay, thank you for the invitation. I just care about the molten salt. If you have some corrosion test about molten salt, just email to me.
Well, thank you very much, and once again, thank you to everyone in the audience and to our speakers. And if you like these type of webinar, well, you can always come to our website, atainsights.com, for more like this. And I hope to see you here next time.